Welcome to Python Data Types Explained for Beginners. In this video, we will walk through every important data type in Python with simple visual examples you can follow along with. By the end, you will understand exactly what each type is, how it works, and when to use it. Let us get started. So, what even is a data type? Think about your everyday life. You deal with different kinds of information all the time. Your age is a number. Your name is text. Whether the lights are on is a yes or no. A grocery list is a collection of items. Python works the same way. Every value you store has a type, and that type determines what you can do with it. The cool part is that Python figures out the type automatically. You just assign a value, and Python handles the rest. Watch as we assign an integer, a string, and a Boolean. See how Python creates each object in memory with its own type label. To check a type, use the built-in type function. Notice the output shows class int for the number and class str for the text. First up is the integer type, or int. Integers are plain whole numbers. No decimals, no fractions, just clean numbers. You can store positive numbers like a score of 100 years, like 2024, and even negative numbers like a temperature of -5. You can do all the math you would expect. Watch as we assign 10 to A and 3 to B. Adding them gives 13, floor division, written with 2 slashes, gives 3 with no remainder, and the modulo operator, the percent sign, gives us the remainder, which is 1. These operators are essential for counting, pagination, and checking whether numbers are even or odd. Next is the float type. When you need precision beyond whole numbers, use a float. A price of 9.99, the value of pi, or a weight of 72.5 kilograms are all floats. Floats and integers can work together seamlessly. Watch what happens when we multiply 8 hours by a rate of 12.50. The result is 100.0. Notice that even though 8 is an integer, Python automatically promotes the result to a float. Heads up though, floats can sometimes give you tiny rounding surprises. 0.1 plus 0.2 equals 0.30000000000. This is a quirk of how computers store decimals, and for most beginner projects, it is totally fine to ignore. Now, let us talk about strings. Anytime you are working with text, you're using a string. Wrap text in single or double quotes. You can measure a string with the len function, which tells you how many characters it has. The upper method converts everything to uppercase, and lower does the opposite. You can access individual characters using square bracket notation. Remember, indexing starts at 0, so name bracket 0 gives you the first character. You can also combine strings using the plus operator, called concatenation. Watch as we join first name and last name with a space in between. And for inserting values into text, f-strings are your best friend. Just put an f before the quotes and wrap variables in curly braces. Booleans are dead simple. They are either true or false, with a capital T and F. That is it. Booleans are mostly used to make decisions in your code. Watch this example. We set logged in to true, then use an if statement to check it. Because logged in is true, the if block runs and prints welcome back. If it were false, the else block would run instead. Comparisons also return Booleans. 10 greater than 5 is true, 10 equals 5 is false, and 10 not equals 5 is true. These comparison operators are the foundation of every conditional in your code. Lists are one of the most useful data types in Python. A list lets you store multiple values in one place. In order, think of it like a to-do list. Items are ordered, and you can add, remove, or change things. Watch as we create a list of fruits, apple, banana, mango. Access items by index starting at 0. So fruits bracket 0 is apple. You can also use negative indexing. Fruits bracket -1 gives you the last item, mango. To add an item to the end, use append. Watch the list grow with grape added at the end. To remove an item by value, use remove. Banana is gone, and you can change any item by assigning to its index. Lists are incredibly versatile, and you will use them constantly. Tuples look just like lists, but with parentheses instead of brackets. The big difference is that once you create a tuple, you cannot change it. It is immutable. Use tuples when your data should stay fixed, like GPS coordinates or the days of the week. Watch as we create a tuple of days. We can still access items by index, so days bracket 0 gives us Monday. But if we try to change an item, Python throws a type error. The tuple object does not support item assignment. That lock icon you see on each element represents this immutability. Tuples are slightly faster than lists and are commonly used as dictionary keys because they cannot change. Dictionaries store information in key-value pairs. It is like a real dictionary. You look up a word, which is the key to get its definition, which is the value. Watch as we create a person dictionary with keys for name, age, and city. Access values using the key in square brackets. Person bracket name gives us Sarah. You can add new keys by assigning to them, like adding an email, and you can update existing keys the same way. But what happens if you try to access a key that does not exist? Python throws a key error. To avoid that, use the .get method. Watch. Person.getPhone returns none instead of crashing. This safe access pattern is one of the most important things to know about dictionaries. A set is like a list, but it automatically removes duplicates and has no guaranteed order. Watch what happens when we create a set of visited cities with Paris appearing twice. The output only shows Paris once. The duplicate was removed automatically. Sets are great when you want to track unique items. Watch as we create an empty set and add tags. Adding Python works fine. Adding tutorial works fine. But adding Python again does nothing because it is already in the set. Sets also support powerful mathematical operations like union, intersection, and difference, which are incredibly useful for data analysis and filtering. None is Python's way of saying nothing. It is not 0. It is not an empty string. It is the complete absence of a value. You will see none when a function does not explicitly return anything, or when something is not found. Watch this example. We define a function called findItem that searches through a list. When the target is found, it returns the item. But when the target is not found, it returns none. We call findItem looking for pencil in a list of pen and book. The result is none. Always check for none before using a value. Use the list of mylid. Use the isNone comparison, not equals. This is the Pythonic way, and it avoids a common bug where none gets confused with false or 0. Sometimes you get data in one type but need it in another. Python makes this easy with built-in conversion functions. Use int to convert a string to an integer. The string 21 becomes the number 21. Use float to convert to a decimal. The string 4.99 becomes the float 4.99. Use str to convert any value to text. The number 95 becomes the string 95. And use list to convert a string into a list of characters. Hello becomes HELLO. This is especially important when reading user input, because the input function always returns a string. Even if the user types a number, always convert it to the right type before doing math. Here is something a lot of beginners do not know until it bites them. Data types fall into two categories, mutable and immutable. Mutable types can be changed after creation. Lists, dictionaries, and sets are mutable. Immutable types cannot be changed. Integers, floats, strings, booleans, and tuples are immutable. Why does this matter? Watch this carefully. On the left, we pass a list into a function that appends 0 to it. After the function returns, the original list has changed. It now contains 1, 2, 3, 0. The function modified the original. On the right, we pass a string into a function that tries to change it, but after the function returns, the original string is unchanged. With immutable types, the original is always safe. This distinction affects how you write functions and how you think about data flow in your programs. In Python, not just false acts like false in an if statement, there are several values that Python considers falsy. 0 for integers, 0.0 for floats, empty strings, empty lists, empty dictionaries, and none. Everything else is truthy. Watch this example. We set username to an empty string, then check if not username. Because an empty string is falsy, the condition is true, and it prints please enter a username. This is a handy shortcut for checking if a value is empty or missing. But be careful. What if 0 is a valid answer, like a temperature reading? In that case, checking for falsy would incorrectly treat 0 as missing. Always think about whether you are checking for empty or just checking for falsy. Here's a quick reference table of all 9 data types we covered. Integers and floats are for numbers, with integers being whole numbers and floats having decimals. Strings are for text. Booleans are for yes or no. Logic, lists are ordered and changeable collections. Tuples are ordered but cannot be changed. Dictionaries store key-value pairs and are changeable. Sets hold unique values only and are changeable, and none represents the absence of a value. Keep this table in mind as you write code. Choosing the right data type for the job makes your programs clearer, faster, and less prone to bugs. And there you have it. You now know all 9 Python data types, how to convert between them, and the crucial difference between mutable and immutable. Once these feel natural, everything else in Python, functions, loops, and classes, will make a lot more sense because it all comes back to working with these types. If this video helped you, hit like and subscribe for more Python tutorials. Happy coding!